look at our next topic, section 3.4, the chain rule. This is one of the last differentiation techniques we'll learn, and it's probably the most difficult. So if you don't get it at first, then that's fine. We're going to do a lot of practice. We've learned the power rule, the product rule, the quotient rule, trig derivatives. We've also learned that the derivative of e to the x equals e to the x. Nicest thing possible, right? Let's just do a little bit of practice really quickly. Number one, what's the derivative of f of x here, right? Well, I guess you could say f prime of x equals, well, that's sine squared of x is sine times sine, so I guess it's going to be take the derivative of the first, leave the second alone, plus leave the first alone, take the derivative of the second, and then do the same thing over here. Well, take the derivative of cosine, that's negative sine. And I guess you could do the same thing here. And, oh, wait a minute, look at that. It's 0. Wait, how could that be 0? Oh, wait a minute. Because f of x equals sine squared plus cosine squared, which we should know equals 1. Of course, f prime of x equals 0. If we had known the identity, we could have saved ourselves a minute. All right, now let's take a look at y of t. What's going on over here, right? This might be a little nastier. Y prime of t. Well, that's going to equal. We're going to have to use a product rule within a quotient rule, right? Low d high. Now, the d high is going to be a little nasty. I'm going to put it in brackets. Maybe make those brackets a little bigger, right? Because here, to take the derivative of this first term, we're going to have to use the product rule, right? So it's going to be derivative of the first, leave the second alone, plus leave the first alone. It looks like it's the same because it, I guess, is the same. Take the derivative of the second. Okay? And now plus the derivative of this guy, right? That's just going to be 35t to the fourth. All right, so low d high, I guess that wasn't so bad, minus high d low. Now remember, the derivative of tangent is secant squared. That's minus 3t squared. Close that parenthesis. Well, I can't quite write it, but it's closing the parenthesis. All right, and then all of this is over low squared. All right, so low d high. And just to be clear, this is the d high part of things. And this is just the regular high part of things, right? And actually, maybe I should be clear. This right here is... Actually, let me be a little clear. This was the part that we had to use the product rule for. Okay, that part. Just be clear, okay? All right, so just want to point out that... we've learned a lot of stuff. We know things that the greatest minds did not know 500 years ago. I think that's pretty cool. You can do things, and I don't mean with a calculator or whatever. You can do things by hand that the greatest mathematicians alive could not do. You could take the derivative of this guy if you really wanted to. And maybe if you wanted an extra quiz mastery, then you would do it and give it to me. So now that our egos are nice and inflated, let's maybe deflate them a little bit. What's the derivative of this guy? Well, we know how to take the derivative of the square root of x, but you can't split the square root of addition over addition. Don't even try. All right, you might have a guess, but we didn't actually learn this one yet. What about number 2? Well, we know the derivative of e to the x. You might guess that the derivative of e to the 2x is e to the 2x. You're not quite right, but you're close. Turns out y equals e to the x times e to the x. So we actually can do this using the product rule. So the derivative of y with respect to x is going to give us, well, take the derivative of the first, leave the second alone, leave the first alone, take the second derivative of the second, and we wind up getting e to the 2x, right? Because just to be clear, this is e to the x plus e to the x plus x. Remember, when you multiply the same base to powers, you add the powers. So this is e to the 2x plus e to the 2x, and that's 2e to the 2x. Awesome. Okay, we actually could differentiate that one. What about number 3? That looks a little. We really could. We could do it if we really wanted to. I really don't. Maybe we could go ahead and. Oh wait, no, we can't do that. Forget it. No, not factoring that out. Nope. Bummer. And then what about number 4? Well, you probably could use some kind of trig identities to make this work, but it'd be a lot of work. I don't know about that. So why can't we find the derivatives of these functions? What is the common theme? All right, just to be clear. The common theme here is that they all are compositions of functions. And what I mean by that is that there's one function inside another function, like plugged into another function. For example, for number 1, right, letting f of x equal the square root of x and g of x equal x plus 1, we can write y equals the square root of x plus 1 as y equals f of g of x. All right, now take a sec to see why that is, right? F of x is the square root of x, and then instead of x, you're plugging in x plus 1. F of g of x. Okay? So you can write each of the previous functions as f of g of x, right? For example, for number 2, right, we have y equals e to the 2x, right? Let f of x equal the outer function, which would be e to the x. So then you would let, say, and g of x equal 2x. So y equals e to the 2x equals f of 2x, right? Which is f of g of x, or e to the g of x, right? We can continue, right? X plus tangent of x to the 500,000, right? Let f of x equal x to the 500,000th, and g of x equal x plus tangent of x. Well, actually, I don't need to put in parentheses, just x plus tangent of x. And so what that means is that y equals, again, f of g of x, right? Note that the, right, x plus tangent of x is going inside. Right, it's getting plugged in for x. Okay? All right, last but not least, what do we have? Sine of 4x plus 7, right? Let f of x equal, well, it's the outer function, right? Sine of x. Well, then I guess g of x is going to equal 4x plus 7. So y equals, again, f of g of x, right? The point is, once you discover what f is and what g is, well, then you can see, okay, y really just equals f of g of x, right? It's a composition of functions. Why am I having you do this? Well, as you might guess, the derivative of f of g of x depends on what f and what g are. So if we can identify what they are, then we can take the derivative. So, fact 1, this is called the chain rule, which we will not be deriving. You can look at it, you can look at the derivation in the book. It's a very technical, not especially enlightening derivation. It winds up equaling f prime of g of x times g prime of x. Right? And another way of writing this is that the derivative with respect to x of f of g of x equals f prime of g of x times g prime of x. All right. Now, I think they prove it at the end of the section. I think it's like whatever. Anyway, ooh, I went ahead and changed that. Okay, I guess we had I guess I mixed that. Yeah, I like that a little bit better. Let's pencil in a 3 right there. Okay, make it a little more interesting, okay? So I guess that would mean that our g of x is actually 3x plus 1, right? Sorry to mix that up on you. But 3x plus 1. Okay, whatever. So anyway, suppose that we have y equals 3x plus 1. Okay, well, let's identify our stuff, right? Even this is a little repetitive, right? But I should say f of x equals the square root of x, and g of x equals 3x plus 1. All right, so using the chain rule, well, maybe first let's actually take the derivative. Maybe f prime of x equals, remember that's x to the 1/2. Derivative of x to the 1/2 is 1 over 2 root x. And the derivative of g of x, that one's a little bit easier. That's 3, right? Right? So, using the chain rule, the derivative of y with respect to x is, well, it's f prime of g of x, right? Let's write that down. F prime of g of x times g prime of x. Oh, what? No, we don't need that second parenthesis, right? And that's going to equal 1 over the square root, right? F prime of 1 over 2 times the square root of 3x plus 1, right? That's what you might expect. But then we have to multiply it by g prime of x, which is by 3. So our answer is 3 over 2 root 3x plus 1. Okay? Y equals e to the 2x. We know our answer is 2e to the 2x, right? We already did it out. But now, if we have f of x equals e to the x, which I guess means that f prime of x also equals e to the x. Right, and then I guess we also have that g of x equals 2x, and g prime of x equals 2. Right, so here dy over dx equals, well, again, it's f prime of g of x times g prime of x, right? So that's going to be e to the 2x times 2, which is 2e to the 2x, as promised. Right, just to be clear, right? Zig, zag, zoop. Right? Zig. I guess I'll sort of do this whole thing, and then zag, and then zoop. All right, so there you go. All right, 2 more. Now I said this was 500, but we know that this is really 500,000. Yeah, go big or go home. So so maybe let's just write out here. Again, we know what f of x is. We know what g of x is. F of x equals x to the 500,000. So I guess that means f prime. So f prime of x equals 500,000. X to the 499,999. G of x equals x plus tangent of x. G prime of x equals 1 plus secant squared of x. So dy over dx equals, well, it's going to be f prime of g of x times g prime of x. So 500,000 x to the 499,999. Oh, except it's not x, is it, right? It's going to be, instead of that, it's going to be x plus tangent of x. Whoop. To the 499,999, right? Because instead of x, I plugged in x plus tangent of x times the derivative of the inside. That's a squared, by the way, if you couldn't. Okay. And last but not least, here, try doing it on your own. Try pausing the video and doing it on your own. F of x equals sine of x. So f prime of x equals cosine of x. G of x equals 4x plus 7. G prime of x equals 4. So, dy over dx equals cosine of g of x times g prime of x, or written a little bit nicer, so that's what we've got for the chain rule. Now let's do a whole bunch of practice. Let's find the derivatives of the following functions. Let me just want to see, make sure this is only, yeah, right, 2 pages. Okay, perfect. Derivatives of the following functions. Let's do it. So you can write out your f of x if you want. When you get good enough with the chain rule, you get comfortable enough with it, you'll be able to just say, oh, look, e to the x is the outer function. G of x is the inner function. So the derivative is f prime of g of x times g prime of x. Right? Here, oh, the outer function's sine, so I guess I'll just take the derivative of the outside function, leave the inside function the same, and then multiply that by the derivative of the inner function. You want to clean that up a little bit, which we should. Look at that. And then, oof, this is kind of annoying. We have a chain rule within a product rule. Barf. G prime of x equals, right? So we're going to take the derivative of this highlight part right here. Lovely, right? Well, it's going to be 7 times x to the 4th minus 9x squared. Again, don't take the derivative of the inside yet. Take the derivative of the outside. Now take the derivative of the inside. Right? And then, of course, keep the second term the same. Right, because remember, this whole thing right here is the derivative of that highlight part right there. All right, and then it's plus, right, and now, easier part, I think, because you just leave this complicated expression alone and take the derivative of this second term, which remember is secant tangent. All right, and just to be clear, this is the yellow part. Underived, right? So with the chain rule, again, please write out f of x, g of x, f prime of x, g prime of x, or not, whatever you feel most comfortable doing. But what you're doing here is you're identifying sort of the first function or the outer function, right? Be careful with powers, right? That you understand that the first function might not always appear first left to right. Anyway, you take that derivative just on the outside and leave the inside entirely the same. Then you multiply by the derivative of the inside. Now, if you've got a whole bunch of nested composed functions, then you just have to repeat that process over and over again. Right? What if we have something like this? That's actually not that bad, right? Here, let's just warm this up, right? We've got f prime of x equals e to the negative 1 minus x squared, right? E to the x is the outer function, negative 1 minus x squared is the inner function, and then times the derivative of the inside, so we get that. What about this guy? Well, I think we could write this a little bit nicer to help us out. F of x equals sine of 5 minus 7 x to the 7th to the negative 1/2, right? I definitely recommend writing it that way. Now, let's take the derivative. So I'm going to write it down here. So f prime of x is going to equal, well, let's see. What is the outermost function? If you said x to the negative 1/2, then you are correct. Take the derivative of that. You know, let me move this. Okay. Anyway, let me move the period up there. Okay. So anyway, it's negative 1/2. Keep the inside the same. Can't tell you how many students get this wrong because they make things too complicated, right? They try to take the derivative of the inside. No, don't do it, right? All I did was take the derivative of this outer function right there, right? Okay, now multiply by the derivative of the inside. Well, look, we have a chain rule problem right there. Take the derivative of the sine part, leave the inside the same, right? I took the derivative only of the sine. Right? Now take the derivative of the inside. Okay, so that's what that equals. Last but not least, let's take a look at this guy. This guy seems harmless enough, but just be a little careful. You are doing a double chain rule, right? Derivative of the outside, derivative of tangent is... Hope we all knew that. Now, multiply by the derivative of the inside. What's the next outermost function? It's e to the x, right? Leave the inside the same. So another derivative? Sure is. Multiply by negative pi. All right. So what about this guy? This guy I actually want you to try and show me in class tomorrow. Show me in class